All right, good morning, good afternoon, or good evening to you all, depending on where it is that you're dialing in from. And welcome to today's webinar, Migrating Your Data Centers to AWS with Automated Security. My name is Don Meyer. I'm part of the product marketing organization here at Checkpoint Technologies. And it is an absolute pleasure and a thrill today to introduce you to our two speakers, Amit Schnitzer, who hopefully you guys are familiar with. He is our cloud security expert here at Checkpoint. Not only is he involved very heavily in the day-to-day understanding of our cloud security portfolio in crafting solutions, but also in terms of helping customers realize a secure blueprint, if you will, or a secure vision with how they can migrate into cloud securely with our Checkpoint software capabilities. Joining us as well is Dr. Alexander Zimmerman, cloud security architect for Accenture. Between the two of them, we are blessed to have a real life use case that we're going to be going through that opens up the door to showcasing a really nice architectural approach towards building in this automated security approach into your public cloud offerings. This use case is unique insofar as that it is a deployed use case, but it's also a unique approach towards looking at how security can be utilized for satisfying a variety of different use cases as well. I'll let the two of them get into it, but before we do, want to offer some housekeeping rules for you guys. First and foremost, today's session is being recorded. A recording link will be sent shortly thereafter the conclusion of this webinar. So you'll be able to peruse again the webinar, go through any of the additional information, or listen to our presentation at your leisure as well. So if you have questions with respect to that, please don't hesitate to reach out to me. In addition to questions, this is an interactive session, or as interactive as we'd like it to be. Therefore, we encourage you to use the Q&A function that's in the lower portion of your screen. Throughout strategic points in the presentation, we'll be answering your questions, and we will open up, time permitting, of course, for a live Q&A session at the end. So I do encourage you to use the Q&A chat box to be able to answer or ask questions throughout the presentation. If you are shy and you're uncomfortable in asking during the presentation, please feel free to reach out to us at any time as well afterwards. So without further ado, let's go ahead and kick it off. And wanted to introduce a concept to everyone on the call before I hand it off to Amit and to Alexander. The concept is, the need for security, the need for a product like a Checkpoint CloudGuard in your cloud environment. A lot of times you hear from the cloud service providers or cloud solution providers out there that the cloud is secure, that these organizations spend a ton of money on building up security into their environment. And that's very, very true. For all intents and purposes, the cloud is secure, and it can be sometimes even more secure than premises-based environments. But make no mistake about it, the cloud is a shared responsibility model, especially for security. Building security to protect that infrastructure and make that infrastructure available is a vastly different discipline than protecting the data and the services and the workloads that you deploy within the cloud. The cloud providers will tell you that if you want to protect your workloads, your data, your applications, that is your responsibility to make sure you put in place the right security mechanisms to be able to do so. At Checkpoint, we've been working very, very hard to build a robust security portfolio to allow you to do that seamlessly, but also still take advantage of all the great things that the cloud has to offer with respect to the agility, the dynamicism of the cloud itself, as well as the automation features and tools that are available to you. Amit's going to be talking a little bit more about that, but make no mistake about it, the cloud is a network. And like any other network, it is vulnerable to network-borne types of attacks. Likewise, known exploits that are out there in the wild can be easily prevented by bringing in intrusion prevention types of technologies or other types of signature-based detection mechanisms. The cloud does not provide those types of tools natively. That is available via third-party solution providers such as Checkpoint. So bringing those solutions into the cloud should be a part of every one of your discussions or every one of your approaches when you start looking at the cloud. And we're going to articulate that throughout the presentation. So bear that in mind. Yes, there's a definite need for bringing security into the cloud. And we hope that the demonstration that we're going to show today, the use case that we're going to present to you, as well as the architectural approach that we're taking, is going to make that transition for you guys very, very easy. With that, it is my pleasure to hand it over to Amit, who's going to go ahead and start walking us through the presentation. Amit, all yours.
Hello, everyone, and thank you for joining this session. I'm thrilled and I'm excited to have that session with you guys. And this session today, like Don mentioned, is all about the use case of one single customer, but we've been having those customers um, for the past few months, so I think it represents a very common use case that probably touches each and every one of you. So you guys already know, and it's been around for a while now. The cloud is by now, it's a norm. So it's everywhere and everybody's talking about it. And customers are vastly moving their workloads into the cloud. So like I said, we're going to talk about and tell you about the customer that is moving to the cloud and how we, Accenture and Checkpoint, join forces together in making that journey for the customer both secure, but also efficient, agile, and fun, if you should say that. So when companies move to the cloud, they usually seek for an efficient operation to be able to scale as well, so grow and shrink based on load. And of course, they want to be agile, so they want to be able to get to market faster. Of course, there's one thing that everybody agrees to. They also want to make sure that the journey to the cloud is also secure. And we've been all over the news. We've seen those stories of companies moving to the cloud and then finding out it's a big deal and they shouldn't be lightheaded on how to do stuff. And this is exactly what we're going to touch on today. And basically the problem or the challenges are that what organizations try to do when moving to the cloud or moving their workloads to the cloud is they try to implement the legacy security that have been used for the past decades, and they try to implement that on the cloud. And some things just don't work the same way. And that's why sometimes we get breaches and we get some issues. So the first thing is that those cloud applications that everybody's launching on cloud, they are not just about protecting the perimeter. They work inside the environment. And so security needs to move also to the east-west, to inside your environment. The second thing about those applications is that they are dynamic and elastic, which means by a click of a button, you're launching a new set of rules, a new set of IPs, new set of names, and workloads get torn down and created by a click of a button. With the legacy security that is rather static, you need to submit a ticket, you need to create a rule on the firewall every time you want to do a change. This doesn't work. If you want to be agile, then some things need to change here. And the last thing is all about the development and the application owners operating in those environments. As we said, the time to market is the key thing. So they treat security as a showstopper because all they know is the legacy security. And what they are familiar with is that you need a ticket and you need someone to do this rule for you every time they set up a new application, every time they introduce a new service into the environment. So this is where the legacy security lacks. And we're going to show you today how we've been able to introduce a new security module that helps facilitate all those challenges and make this journey not only secure, but also agile and elastic as the cloud could be. So like I mentioned, this journey started for me at least 6 months ago when I visited a very large European power utility company. And I was visiting them and I was amazed because their strategy was all about, listen, in 5 years from now, we're not going to be operating in an old on-premise networks. We are actually moving all of our workloads into the cloud. And by saying cloud, it's 80% on top of public clouds. And public clouds is not just a single vendor, but a mixture, like a multi-cloud configuration. And also 20% of the workloads are planned to be in a private cloud. So this customer was a big paradigm change, at least for me, because this is a very huge customer. It's 100,000 employees in over more than 100 locations, 25 billion euro revenue. And these guys were saying, listen, we're moving everything to something they refer to sometimes as cloud first and cloud only eventually. And so their drivers for moving into the clouds was A, improving performance and the availability of their services, IT services. B, enhancing the cost control by standardization. So being able to use the compute components with their finance calculations, etc. And of course, like I mentioned, reducing the time to market. So it's all about how do we make our applications launch and be available for our consumers and for our business faster. So with that, I want to transfer the session to Alexander, who will tell you in more details of the architecture he was building for this customer. Alexander.
Thank you very much, Ahmed. So before I go into that here into the topic, I would like to give you a little bit more background. So actually, I'm now with the client for more than 2 years, and when we came to the client had already a big footprint in the public cloud. And what we saw was many accounts, but there was and subscriptions, but there was scattered around. And we found our roughly 200 subscription in public cloud subscription. And the reason why we have this huge number of subscription was that for each project, they ramp up a new subscription. And with this, we saw two main problems. First of all, governance. So we have no central point, security point, but also governance point with that. So for example, we have an application owner that's very similar, very familiar, with security. They take care of security. Maybe they have already an enterprise grade firewall in their account. They are familiar with routing and so on. Everything's secured. But on the other hand, we have also application manager that are not so familiar with the cloud. And the second thing is, if you have this huge number of subscriptions, you need to reinvent the wheel all the time, because you need services like DNS, like AD controllers, and you need to set it up in all these accounts. And when we would like to start here from scratch, our idea was that we would like to build, let's say, a legacy data center in the cloud. So we would like to give the client a common landing platform where we can migrate all applications that we have in the legacy and can put it to the cloud. And the main goal was that we would like to have, end of the day, central point where we can implement governance. Saying that is how we can implement this security. Amit, can you give me the control? Now I thank you very much. So how we can implement this governance? So it's all about, first question, number of accounts. How many accounts do we need at AWS? Of course, and you would like to migrate a large footprint into the cloud, you know already, okay, you cannot live with one account. You need multiple accounts. And then the next question is, how many accounts do you need? And what we see with clients and also best current practices from the AWS, we can set it that we have a couple of accounts that we need. And what you see here, at least, we have 3 types of accounts. One account is a so-called billing account, is a pair account. You know that you can connect all accounts that you have connected to one central payer account, so that all finance will show up in this account. And then your finance people get access to that and to this account, and then you can backcharge it to the different application manager and so on. Then we have a second type of accounts. It's accounts for your workload, and the owner of these accounts are normally the application manager. And the last component, what we see is actually the accounts where we can implement the central governance. And these are mainly the security accounts. And the owner of these accounts are the IT people, for example, security people. The last question that always arrives here: how many applications account do we need? And this is a question. It's hard to answer. It's not one answer to that question. A good rule of thumb is choose something where you can segregate your data. What we do here at a client, we segregate across different security principles. So we have applications with high security standards, and we have applications with less security standards. And therefore, this is our metric where we separate data. And the last question that always arrives: why we separate in different accounts and not, for example, with one in account and with different VPCs? An answer to that is the so-called blast radius. So the highest possibility where you can segregate your data is an account. If you have an issue in one account, for example, you delete by accident one CloudFormation template, and you delete instances or some central configuration, it's only affect the one account. Or we hit a limit in auto-scaling cluster, it's only limit one account. Okay, now we would like to go a little bit deeper, how we can implement our governance with these central security accounts. And when you think about traffic flows, what traffic do you see in the cloud at 10,000 level foot? You have traffic from and towards the internet, and you have traffic from and towards your on-premise data center. And here we take first we take a look on the traffic that this goes to the internet. What we implement for the client was, first of all, we have a DMZ. This is an account where we put firewalls, and here we handle the traffic from and to the internet. What you see here is that we have a separation between workloads, productive workloads, and development workloads. The decision to do that was, that you have normal, in a big company, you have processes, how firewall rules get approved, firewall approval process. And very often this process also not cloud ready. For example, when you have DevOps environments, you would like to ramp up new services quickly, and also you would like then to open the firewall quickly. We have no issue with that because we have no productive workload there. However, on the other hand, with the productive workload, you would like to open the firewall in a more conservative way. In order to do that, to have a slim firewall approval process, we separated the firewall into these two different parts. And on the other hand, when we do that in the DMZ level, we also need to do it on a workload level. So here, what you can see, we have three stages: productive accounts, Q&A accounts, and development accounts. So the Q&A and developing are connected to the DMZ and to Dev and Q&A DMZ, and the productive is connected to the productive. Another fact that you can see here is that we have a separation on the workload accounts between public and private. What does it mean is, you have applications in companies that do not need to have accessible from the internet. It's only for people inside the company. On the other hand, you have, for example, you need to host your web page, and this is a service that you need to promote to the internet. And in order to segregate also on this level, yeah, we have the separation if our accounts have an access to the DMZ or have not an access to the DMZ. The second component that we have, besides the traffic to the internet, we have the traffic towards on-premise. What we implement here is the so-called transit setup. It's a setup that is familiar for people in the, that work with AWS. Is a common best contract practices how you route your traffic to on-premise. What does it mean, transit account? In a big company, you spin up a direct connect from AWS. It's an MPLS connection from on-premise to AWS. And then you would like to route this traffic to all your application accounts. Why do you do that with a central account? It's because you do not want to have multiple MPLS connections. However, how we implement this connection here? Because you need to route the traffic from on-premise to application. And simply make a simple connection between the transit and the application account doesn't work on the. So in terms of AWS, it's a peering. It doesn't work because the peering at AWS, it's not transitive, so you cannot route it. Therefore, you need a third-party device that route for us. In our terms, is a checkpoint firewall. So our checkpoint firewall not only filters the traffic from on-premise, but it also routes the traffic. So if you have an application would like to talk in account A, would like to talk to an application in account B, it goes to the firewall, get routed and get back to the application. And how that it works, it works with BGP. The third components, how we implement the governance, is a so-called shared service account. If we implement a couple of application accounts, these application accounts normally need to have different services like access to an Active Directory controller, or maybe you would like to ramp up a Citrix environment, or for example, services for semantics and so on. In order to do that, we have basically three possibilities. Either you implement all the services in each account. It's maybe not the best option, because you replicate all the services in each account, and this is quite cost expensive. Another possibility would be, because you have normally all the services also on-premise, you can route this traffic back to on-premise. Downside from this is you have a higher latency. Think about DNS. And of course, you need to open the firewall wider. So here at the client, what we did, we ramp up one central service account where we put all the services together and then connect this shared service account with all application accounts, and how we connected it with a normal peering. In order to do that, we have low latency for all the services because we host the services in the cloud. On the other hand, it's not necessary that we open the firewall for every application, because end of the day, we proxy this with the shared service account. So it's only a one-to-one relationship that we need to open on the firewall. The last component is our application accounts. So we have three central components. Now we talk a little bit how we implement the application accounts. For the application accounts, we decided to implement a three-tier architecture. It's a normal three-tier architecture that you find also on-premise. What is worth notice is that in all application accounts, we have no internet gateway at all. If you would like to have a service that needs to be accessed from the internet, it goes all over DMZ. So actually the elastic IP address, our routable IP address, is sitting in DMZ. Then it gets routed to the firewall, and from the firewall, it gets to the presentation layer, and then to the application tier and database tier. How it's really connected, I would like to show you in more deep later in the presentation. I would like now to hand over again to Amit, and Amit will show you how we set up the firewalls in this environment. What are the options the Checkpoint give us to implement this?
So thank you, Alexander. So we've been called by the customer, and Alexander did an amazing job, like he just showed you guys. And we were asked to integrate and implement our solution into that design, into that 3-tier multi-account, multi-AZ configuration. And what we did was implementing what we call our cloud security blueprint. And basically what it's all about is to fence the environment. And when I say the environment, you can see spokes. So actually the whole idea is basing it on a hub and spoke configuration, where each spoke here in the diagram is an application environment. So an application owner creates an environment, and this complete environment is isolated from the rest. But basically, we are fencing all those accounts under one wall, I will guess, better said. And then what we did into that environment is to systematically separate between traffic coming from the internet and between traffic going into the internet. And basically, those two checkpoints, I guess, those two connections are the only ones available into the environment. And so what we did was implementing a hub, an environment which is a hub on top of those two gates. The first one is also referred to as the northbound hub, and the other one is the southbound hub. So once again, northbound hub is used for incoming connections from the internet, and the southbound is usually for connections going to the internet. We've implemented CloudGuard gateways into those hubs. So then every traffic going in or out of the environment goes through those gateways. And so the network and security guys who owns the hub accounts, like Alexander mentioned, have full visibility and control of the traffic flowing into the environment, but also out of the environment. We then connected the hubs to each of the spokes. And so connectivity coming from the internet, from the northbound, will first hit our firewall, and then we'll continue the journey into one of the applications based on the destination. One thing to note here is that those connections from the northbound to the spokes is based on peering, and like Alexander mentioned, this is non-transitive. We actually use this limitation, so to speak, as a security measure. So then even if someone gains control over one of the spokes, there is no way by definition to traverse through the network that way from spoke A to spoke B. So that is by design is blocked. Actually, traffic between the spokes is being done through the southbound hub, where, like Alexander mentioned, we created IPsec connectivity. Because of that limitation of being transitive, we've implemented VPN between each spoke and between the transit southbound hub, and then implemented routing on top of that connection. Like Alexander mentioned, we've implemented BGP. The reason was for the automation and agility. We will touch that later on. Another thing that we did was to connect the southbound hub into the on-premise network using the MPLS connection. And basically, so this is our best practice conceptual approach. What we did with this specific customer was to actually divide this southbound hub into two roles, one of them doing the on-premise connectivity and the other one doing the outgoing. So basically speaking, in this specific customer, we actually implemented 3 hubs. One that is a northbound for incoming traffic from the internet, second one that is southbound hub into the on-premise, and another southbound hub connected to the internet for traffic going into the internet. And I want to make a note here and make sure that you guys understand that this blueprint that we came up with, it's a conceptual, it's a high-level best practice approach, but it's common and it happens every time and again. When I meet customers and I sit with them for a design session or an architectural review, each customer has its own unique requirements. And basically what we're doing, we're taking this best practice approach and then bend it a little bit and adjust it to make sure that it fits the customer use case. So this is exactly what we did here as well. Alexander, can you share your insights into this great slide?
Sure. So recap what I tell you before is that we have a couple of central components where we implement the governance. Yeah, this was the DMZ, the shared service, and the transit. And on the other hand, we have our workloads. Traffic flow towards internet, from the internet to on-premise and from on-premise. Now I would like to go one step deeper, how we connect these landing zones together and what was the possibilities that we implement there. Let's start with the internet incoming traffic. Yeah? So at the internet incoming traffic, here our internet is somewhere here. Yeah? We come over our internet gateway in our DMZ, and then first of all, we hit a load balancer. So the load balancer is a place where we implement all public IP addresses. So the load balancer implement our elastic IP addresses. So as I said before, we have no elastic IP addresses at all for the workload. So even by an accident, we ramp up in service with an elastic IP address, it's not routed because we have no internet gateway here. You cannot access this service by accident. Everything goes over the firewall. This load balancer then forwards the traffic to the to our firewalls. The firewalls are implemented in a normal auto-scaling cluster. This auto-scaling cluster it's automatically deployed by a CloudFormation template by Checkpoint. You can download it and implement it in just 20 minutes. Yeah, it's a normal auto-scaling cluster. How you implement an auto-scaling cluster also with a load balancer, with a normal web service at AWS. Yeah. If you have more load on the firewalls, yeah, the auto-scaling cluster ramp up more firewalls. If you have less traffic, it shrink down. For our Q&A environment, we implement a minimum of 1. For productive, we would like to always have redundancy. The minimum is 2. On the firewall, the traffic get nutted, and then over a peering connection, it goes down to the actual workload. Here we have our 3-tier architecture, and then the traffic get routed to the instance. Here is a normal IP routing. The other way around, yeah, we have here an application that would like to talk to the internet. Yeah, on routing terms, what does it mean talk to the internet? We have a default route. So the question is, or what you would like to do is, you would like to put your default route to your Checkpoint firewall so that every traffic that goes to the internet get firewalled. Now at AWS, you have a couple of options how you can do that. The easiest way would be you you implement your default route in your routing table by put this route to an instance. Yeah? In the routing table, you choose a destination, your instance ID. However, if your instance is not in the same account, this instance ID is not visible. So in our setup, it doesn't work because here our DMZ is a different account than the workload. So I cannot route to an instance which is not in my same account. The only option that I have here to do that is if I ramp up a VPN connection and then I promote via BGP the default route here. So actually all this here are VPN connections. Also for this, we have worked with Checkpoint together and we have now a solution that it's a ramp up automatically. Amit will show it in a demo later on. So actually all these VPN tunnels created are automatically. And the only route that this guy announced via BGP is the default route. On the productive environment, we have redundancy. Both firewalls promote the default route. One promotes with a lower metric than the other one. So the traffic goes to one firewall. If this firewall goes down due to an accident or due to an issue that you have, failover is then handled by BGP, so the traffic will route it to the other firewall. This is what Amit showed you before, one implementation of the southbound. Exactly the same we have with the transit. So also on the transit, we have VPN connection to all the account. The only difference is this transit here doesn't promote the default route, it promotes the route from the on-premise data center. Like every other big customer, we use a 10 IP address range. So what we announce here is also only one route, it's a 10/8. So every traffic, what is not locally, it gets routed back to the transit. The transit knows all other routes to the other accounts. So if the transit see in its routing table, yes, there's another account, it's routed back to the other account. If not, it go back on premise. And last but not least, we have the shared service account, and the shared service account is connected to each account with a normal peering. That's it. And now I would like to hand over again to Amit, and Amit give you a short demo how it looks like in real life.
Yeah, so thank you so much, Alexander. I'm being a little brave here because I'm going to show you a live demo of the automation that Alexander just mentioned. So what I did in my environment was actually setting up the transit VPC with our two single separated gateways connected with an IPsec to two different spokes and managed by a management sitting on a service VPC. What I'm going to show you is that whenever I tag a spoke, then the management server is able to automatically configure and create the VPN connectivity and the BGP route redistribution into the transit, thus allowing this spoke access both to and from other spokes, but also connectivity to the internet, which is what the transit VPC is all about. So let's put that in motion. So here's my R80.10 management implemented on AWS. And you can see the policy. By the way, I used native Amazon objects. So I did not use objects that are created statically on the firewall management, but actually I have created an integration between the management server and between Amazon. So now I can pull objects into my policy directly using objects from Amazon. So for example, I can add any of the objects that reside on my Amazon subscription into my policy, just clicking on plus and they will be added. The benefit here is that those objects are completely dynamic. So whenever they change on the platform side, on Amazon in this example, they almost instantly, within 30 seconds, they will also automatically refresh and update both here in the GUI, but also on the policy itself, which means they will be enforced and inspected. But the management server is just, it's not our focus of the session. What I do want to show you is the Amazon environment. So like you can see, I have 5 different instances, one for the management, one for each spoke VPC, so spoke 1 server, spoke 2 server, and my transit firewall gateways residing in the transit VPC. If moving to the VPC configuration, I have 4 VPCs, one for the management, one for the transit, and one for each spoke. By the way, spoke A is already connected with a VPN to my transit, and I can show it here in my VPN community. So there is a VPN community I created. It's called Blueprint Community. You can see it's a star community where the central gateways are the transit gateways residing in the transit VPC. And as you can see, there's satellite gateways. Those are interoperable devices configured automatically by the management. They each represent the VGW connectivity to the specific spoke. What I'm going to do now, I'm going to tag spoke B, which is not yet connected here. And what you're going to see is you're going to see 4 new interoperable devices appear here in the community. You're going to see the policy being automatically installed. And basically, this VPN connectivity and routing magic is going to happen on the background. Without further ado, let's do that. So it's all about creating the right tag for that VPC. I actually have that tag already. I just need to comment out this first character. So by the way, this tag has the management configuration, which management is handling, and also to which community to add this spoke. As you can understand, we can have multiple communities, multiple accounts, multiple management servers, each serving different applications, each serving different use cases. So it's very flexible. Hitting on save. What's going to happen now is that our management server is going to identify this new tag that we just created, and we'll start creating the VPN tunnels into that VPC. So from the Amazon perspective, we're going to see some more coming up soon. And from the management perspective, once it's scanned and configured. And what I'm going to do here is I'm going to connect to one of the gateways. And I'm going to access one of the servers, the one that is on spoke 1. So I am connected to this server, by the way. So spoke 1 server has access to the internet. I can also do wget, cnn.com, for example. And as we speak, the management server identifies this new tag that we've created, and it's creating the configuration on Amazon side. Once it's up and running, we will be able to also access this server on spoke B from here, from this server on spoke A. So if we track the changes being done, you can see there's 2 new VPN connectivities pending. So our management server, while we're talking, while I'm resting here, is doing all the hard work. So it's connecting, it's creating the VGWs, it's creating the CIDR blocks, it's creating that the routing is dynamic, so it's going to redistribute BGP routes. So any IP address range that we've created for that spoke is also going to be redistributed into the transit, and vice versa. The transit is going to send the default routes to that spoke, so servers on that spoke know that the next hop for them is through the VPN, through the transit VPC into either other spokes or to the internet for that matter. So in a few more, let's see what's happening on the management. You can already see policy being pushed automatically. I'm just moving back and forth, but you can see things happening without me doing anything. So just refreshing the view. I suspect to see more than 4 gateways by now. So here is the 5th, and it's going to do some more configuration done. So this whole magic is being done by the management server, and this management server can reside either on Amazon or on-prem, or even any other environment for that matter, even Microsoft Azure, Google Cloud, any platform that we support could also be, you can run your management from. So we should wait till the configuration ends. So that's a matter of couple of minutes. And you can see it's still being configured. And once it's done, we should be able to also ping. So this server here is 172.16.172.104. Actually, the other spoke is on 173.104. So I can try and ping and wait for it to come up when it's done. And you can see it's still being configured. But once again, we tend to be impatient with everything coming with automation. But you can already see one of the tunnels coming up here. I'm just hitting refresh every now and then. And when it's ready, you will also see the traffic traversing from one to the other. So that's what it is about. And of course, if we talked about visibility and control, all this traffic is also visible on our policy. So you can see all the traffic accessing into the environment, but also traffic going out of the environment. So let's see it soon enough. Yep. So what we see here is still BGP redistributes and VPNs be coming up. It's going to take a few more seconds, and then we should be able to access each other and to the internet. Yeah, we already have all 8 interoperable devices. By the way, why is it 8? Because each transit gateway has 2 connections to each of the VGWs, and each VGW is actually doubled. So actually each transit gateway has 4 VPN connections to each spoke. So we're having 2 spokes, that's a total of 8. Right. Let's check our status of our VPNs. Like I said, we are brave. So this is up, and this is also up. I expect to be able to ping one another pretty soon now. Yeah, it's already working, like you can see. And let's find the logs to show of that ping. So here it is. You can see it. And you can see it's being encrypted. And basically, I can also try to SSH into that other server on the spoke VPC too. So here I'm doing this. Here we go. Yep, here I am. And I can also ping, I should be able to ping Google or wget to cnn.com or nba.com, wget. nba.com. Let's change that. Yep, here it is. And of course, everything is on the logs. I have full visibility. I have full control. I can change my rules to match my security policy, security posture. So that's pretty easy. And we're showing simple firewall rules. Of course, we can also implement threat prevention, layer 7 protection, deep packet inspection. That's really what it is about. It's not just about. But I think you got this picture. We're all about the automation and this blueprint configuration and architecture. So going back to our presentation, wrapping up what we just showed, the security architecture that we've introduced to the customer is actually allowing it to be agile. So like I showed you, every new spoke, every new application owner creating his own environment can connect it automatically and protect it automatically just by tagging it correctly. It automatically connects into the transit. It automatically gets into the policy. Since we're using dynamic objects, we're not using statically created objects on the firewall. This allows us to create rules based on tags, based on an entire VPC or a subnet or anything that is Amazon native you can implement inside your policy. This solution is automatic, so it's based on a cloud formation, Amazon cloud formation. You don't need to create it and implement it step by step. Everything is automated as well, even in the creation. Same thing goes for Azure. There's a solution template ready for that implementation. And like we mentioned, this security architecture allows the IT guys, the network guys, the security guys to be in full control of their environment. This is a key thing because in today's world, the developers, the application owners, sometimes they work around IT and networks. They allow themselves access to those cloud environments. And some bad things can happen when a developer who did not understand the meaning of creating a public IP directly to the server. We've seen that with Tesla, for example, where a server has been hacked because someone has created an RDP connection with a default password. That's what could happen, but this cannot happen when your security guys are in control, when you have full visibility into the environment, where you have full control what is allowed and what is not. So this is what it is. And like I mentioned, our architecture, our products allow our customers to implement their solutions, their workloads, their business, their applications across multi-cloud environments. And in today's world, and what we see in the field is that a lot of customers, they're not using only one vendor. They actually always think and talk about multi-cloud architecture strategy. And with using our management, you can have a one unified management server located anywhere you want, whether on the cloud, on-premise, anywhere you want. And then connecting those cloud environments together as if they were one, and to have a single access rule within that unified policy. And you can mix and match between, for example, Amazon Web Servers want to access DB servers on VMware, for example, on your on-prem. This is possible using that dynamic nature and unified nature of our management. When we take a zoom out of just talking about Amazon, and by the way, this is also relevant for the customer use case we just mentioned, because this customer, this is the first stage for them. The second stage is to start implementing Azure environments. So looking on this blueprint and the architecture principle we just showed you, we are able to use the same design across multi-clouds and to have one management, for example, either on-premise or any on the environment, to have control and visibility throughout the workloads wherever they are. So for example, you can have your web servers accessed from the internet on your Amazon northbound VPC, then accessing the application tier. The web server goes to the application tier through the southbound hub, like we've showed. And then this application server in a three-tier common scenario can access the DB server located on Azure through the VPN connectivity across the multi-cloud and have one rule unified rule between those environments and to allow this type of connectivity. So this is what it looks like from an architectural multi-cloud perspective. And so to summarize what we've seen, the security blueprint and what we've practiced with this customer allow them and empower their way of innovating, allow their application owners to create their own environments and to be able to work even when their IT and network guys are asleep without losing control or visibility. It enables fast and robust scalability, so you can grow and shrink, and you can use changing performance capabilities across your environment. And like I mentioned, you can also connect multi-cloud environments together. With that, the presentation has come to an end. Don?
Amit and Alexander, both, thank you so much for this wonderful information. And as you can see, there's quite a lot of context behind what our philosophy is. You know, ultimately, in looking at the cloud and looking at, you know, what we're trying to accomplish with the cloud, the things that make the cloud so attractive, the elastic nature of the cloud, the automated nature of being able to provision new services and new applications, make it very, very attractive. When we start looking at bringing security in, we can't use the old monikers, to Amit's point, about being so manually intensive. Any change that we want to make to that infrastructure should automatically be absorbed by that security infrastructure. And that's why, you know, our philosophy with respect to this architecture, if you will, really does benefit not only this particular scenario or this particular customer, but offers a lot of different opportunities for a variety of different use cases as well. We have a couple of minutes left, and so I want to be respectful of everyone's time, but we do have some questions in queue. So Amit, are you ready? Let's go ahead and start tackling some of these questions right off the bat. First and foremost, a lot of people have asked, is this session being recorded? Yes, this session will be recorded, and I apologize if folks were experiencing some audio delays. From my end, I did not hear or experience the delays or any audio issues. So my hope is that with the recording, the audio issues will have been resolved. So we'll send a link out to the recording for all of you who have attended sometime later on, either today or tomorrow, with the link to the recording that you can then peruse at your own leisure, revisit any of the topics, and hopefully that cleared up the audio issues. Secondly, folks have asked, are the slides going to be available? Yes, we'll post them to a SlideShare site. We'll make them available for you guys as well, so you can go through the slides as well as listen to the audio and watch the video again. Getting into a little bit more of the details, Amit, this one's directly to you. And this question comes from an attendee asks, how do you use an account to provide security to other accounts on AWS?
So the way to do it is to have a root account that manages and has like a roof for all the rest of the account. And then you can dictate a policy of what the spoke accounts can and cannot create. That's basically how you do it. So it's all different accounts, but they all under one root entity that is dictating the policy and that kind of behavior across.
Perfect, thank you. Next question comes in from Emmanuel Darby asking, in terms of the different spokes, so you have the northbound spoke and you have the southbound spoke, or hub, I should say. What are the differences between these? And what is the advantage of using a different ingress and egress point for the internet?
So what we did here was systematically separate between incoming and outgoing. The logic behind this is so that you have a systematic approach of which direction of traffic you trust more and which one you trust less. It actually comes for two reasons. One is to avoid human errors exposing your network because you wanted to do something outgoing to the internet, but undeliberately you created a hole for your incoming. The second is that in some of the customers, we saw that there's different policy, sometimes different teams handling those two different environments, traffic to and from. And so, again, this is a best practice approach, and we usually recommend of following it, but I've seen customers also merging those two together. So this question is a great question, repeating itself. For some, this may not be, doesn't make sense, so you actually merge them together and you say, you know what, internet is one thing, the rest is a different, so you can separate that by that logic anyway.
Fantastic. I'm sorry, go ahead, Alexander.
Yeah, one sentence to add. It was mentioned that the traffic is, it's not that when the internet traffic comes in, yeah, it not goes out over the other firewall. Yeah, so what comes in goes out of the same firewall. Yeah, but I think that was not the question, but to be clear on that. Another point is we need to separate the ingress from out egress internet is simply because in our setup we choose an autoscaling cluster for the incoming traffic. And a technical limitation that we have on AWS, I cannot ramp up my VPN connection to the autoscaling cluster. It's not supported from AWS. Only when you have HTTP traffic, we can do that, but we have other traffic than HTTP. So I was, let's say, forced by the technology.
And I think that's a very important point. Yeah, I apologize for stepping on you there, Amit, as well. A lot of what we're experiencing, and hopefully you guys are seeing the same things as well, is that the different public platforms that are available to us, they do things a little bit differently. They try and accommodate as many common use cases and common workflows as possible, but they are constructed a little bit differently, and they have their own unique characteristics. The reason we chose to go in this path is it offers us a lot of flexibility with respect to how we accommodate some of the restrictions within that environment. And Amit, if you wouldn't mind, just filling in a little bit more detail there. I apologize for stepping on your toes there.
No, it's fine. So this is exactly what I wanted to say about this. Was a great point.
Perfect. So we have another question in queue that says, what if internet services need to initiate connections back to the hosted application based on their source IP address? Will this be allowed in our design? And if so, does it not circumvent the design?
So answering this, whenever you publish a service to the internet, it's based on today on the public IPs represented on the DMZ VPCs. So if you're referring to a source IP, we can do something like that, use those IPs and then have someone go back to those IP. But from a standpoint of having a server from the southbound access to the internet and then traffic going back to that IP on a separate session, because on the same session it will work, but on a separate session, this is something that systematically we did not handle. Usually there is no case like this, but if there is, I'm guessing we can create something on a shared architectural design with the customer or anyone who's interested.
Excellent. Thanks for that, Amit. And again, we've got a couple more questions in queue. For those of you who are still with us, if you'd like to ask any other questions, please go ahead and use the Q&A box there. Next question comes in asking, how much more time does it take to, oops, I'm sorry, they just removed that question from us. So we'll move on to the next one.
I answered it. I just answered it.
Perfect. Thank you, Amit. Next question. Are we natting IPv6 as well?
So that's a question I need to check back because this is, I haven't faced that myself, so I need to check it and then answer. I don't want to answer something that I'm not 100% sure of.
Very good. Good point of, and good rule of thumb as well. Last question we have in queue before we let everyone loose is, Spoke apps can be implemented on infrastructure as a service or platform as a service?
Oh, that's a great one.
I can cover if you like, Amit.
Yeah,
thank you.
Yeah, simply question, everything that sits in a VPC, you can cover. So yes, when we have an RDS database, yes. something that is not sitting in a VPC. We have no control on the routing that is hard.
Yes, and I add to that there's a private link, so you can have your PaaS application, platform as a service application, connected on a private link into your VPC. Then yes, you can have a spoke apps that are PaaS oriented inside your VPC, and that will work. Yes.
Fantastic. All right. Thank you, gentlemen. And thank you all for attending. And hopefully you found this information not only interesting, but also quite useful as well. If you have any other questions or you would like to reach out to any of us, please feel free to hit us up via email. As you can see, Amit and Alexander's email addresses are there on the screen for you. We'd be happy to do some follow-up conversations. If you'd like to see a live demo in your environment as well, please feel free to reach out to us. And keep those questions coming. We really do appreciate it and hope, again, that we get the right information out to you to help you make the most of the cloud, but more importantly, keep security first and foremost in everything you're doing in the cloud to avoid unnecessary exposures and to avoid your cloud services being focused for attack. With that, on behalf of everyone here at Checkpoint, everyone at Accenture, thank you so much for your time and attention. We really do hope that you enjoyed today's session, and we look forward to seeing you on future sessions going forwards. Go out and have a great day, everyone. Thanks again.